Right, this is just a brief video to show you all about reversible reactions and explain reversible reactions to you, okay? Only take a couple of minutes. So some chemical reactions are reversible. You'll know if they're reversible if you see this sign, okay? So it looks like two half arrows. That's when you'll know something is reversible. That means it can go in either direction. The reactants will make the products and the products will make the reactants again. So it goes back and forth and back and forth. Not like when a reaction like that, that's just a complete reaction, no ability to go backwards or forwards. Okay, some things affect whether you make loads of reactants or loads of products, okay, because they aren't just reactions where they finish, they can go back and forth and back and forth. So certain things, and you need to know about 3 things that can affect the reaction by changing the conditions. So when a reaction occurs in a closed system, i.e. no reactants are added or taken away, and equilibrium is achieved. In other words, the reaction goes the same rate in both directions. That's known as dynamic equilibrium. So you're not adding any more reactants, so you will reach essentially a constant where you've got the same number of reactants and the same number of products. Okay. So what happens to change the conditions of the equilibrium, and what does this do to a reaction? So we can use Le Chatelier's principle to work this out. Le Chatelier's principle is covered a lot more in A-level, but you need to know a little bit about it at GCSE as a triple scientist. So you need to be able to look at how changing the concentration, changing the temperature, and changing the pressure will affect an equilibrium. Okay, and Le Chatelier came up with this principle. It was called, if the system is at equilibrium, a change is made, the system responds to counteract the change. Okay, and he came up with 3 different things. Number 1, he spoke about increasing the concentration. So if the concentration of reactant A is increased, so remember we've got our reactants on this side and our products on this side. If the concentration of the reactant is increased, the system is no longer at equilibrium. What will happen is more products will form. So if you increase the concentration here, it will react to then increase and make more products, okay? If I increase the concentration over here at D, that would then react and increase and make more reactants, okay? Only because it's at equilibrium, it's a reversible reaction. The reason they do that then is to make sure it restores the equilibrium so you've got even numbers on both sides. So that's what happens if you increase the concentration. Secondly, he looked at changing the temperature of a system, okay? And you need to know what would happen with both an endothermic and an exothermic reaction. With endothermic reactions, they like to, if you want to get to the products, you need to increase the temperature. So endothermic reactions, they need an increased temperature to get more products. If you decrease the temperature, it shifts the equilibrium back towards the reactants. Okay, with exothermic though, it's a little bit different. When you increase the temperature, you end up with more reactants. Okay, so they favour a decreased temperature, and an awful lot, they will say to you something like H2 plus O2 goes to this. Okay, and it's got a value of 330 kJ per mole. Okay, so that means that it's an exothermic reaction. An exothermic reaction then, so how would you make more products? The kind of question they would say. And to do that, you would decrease the temperature. The reason we decrease the temperature, okay, is because that is what is favoured in that type of reaction. If it was a positive endothermic, then actually to get more product, we would increase the temperature. So you have to remember what type of reaction favours what. But they'll always give you information as to whether it's positive or negative, endothermic or exothermic. And then finally, we can look at increasing or changing the pressure. Okay, so to work out what would happen in terms of increasing or changing the pressure, we need to look at the number of moles on each side, or the number of molecules on each side. So imagine there's a little 1 in front there. So you've got 1 plus 3, you've got 4 molecules on the reactant side. On this side then, there's a 2 in front, so you've got 2 molecules on this side. Okay, an increase in pressure will push the reaction towards the side with the lowest number of molecules. So for this, it would favour going towards the product. Okay, so low, so increasing the pressure goes to the side with the less molecules. So if you're trying to get it towards the products, that wouldn't actually work if you had 4 on this side, but 10 on this side. You would then have to decrease the pressure to go to the side with the more molecules. Okay, so when you increase the pressure, it goes to the side with the less molecules. So by increasing the pressure, if it was 10 and 4, it would go towards the reactants, which wouldn't help you make more product. So there is 3 principles, and you need to know and be able to explain them.